So anyway, I do remember that because I remember sitting there for hours having to cut all these papers out. My mother tortured me for hours upon hours to make sure I could cut. All right, so first of all, let's talk about what the question is asking me for. What size squares should be attained to the largest volume? So obviously the formula I'm going to have to use that I'm going to want to maximize is my volume of this particular box. Does anybody remember what this volume is going to be? Length times width times height. So in this particular example, ladies and gentlemen, remember, I started with this full 30-inch by 16-inch sheet of cardboard. But now notice I'm cutting away those squares. So what is the length of this particular sheet of cardboard going to be? 30 minus 2x. The other side, again, has a side length of 16 inches. But notice I'm cutting away those two corners. So the width then is going to be 16 what? Minus 2x. Times the height is just going to be x. Again, you could look at the two boxes I illustrated. The height is one of the sides of the square, which is x. So any questions on that? So now, remember, this is the formula that I'm going to have to take the derivative of because I want to take the derivative of the volume formula because I need to find my max and my min. So before I do the derivative, yes, you are going to need to multiply this out. You're going to want to multiply this out. So I'm going to go ahead and distribute that x first. So that's going to give me 16x minus 2x squared. I'm going to go ahead and I'm going to FOIL this. So my volume, 30 times 16. 480. And then I'm going to have my outer terms, 30 minus 2x squared is going to give me a minus 60x squared. Negative 2x times 16x is going to give me a negative 32x squared. And then 2x times 2x squared is going to give me a positive 4x to the third. Combine my like terms. So my volume is going to be equal to 480x minus 92x squared plus 4x to the third. So any questions so far on how I just, again, you want to simplify, clean up that volume formula as much as you can before you actually take the derivative. So now I'm ready to go ahead and take the derivative with respect to x. So I'm going to take the derivative with respect to x. Derivative of 480x is going to be 480. Derivative of negative 92x squared is going to be minus 184x. And then the derivative of 4x to the third is going to give me a positive 12x squared. So now to find the candidates that's going to help me figure out what size squares this is going to have to be, I'm going to go ahead and set this derivative equal to 0. And I'm just going to rewrite this as 12x squared minus 184x plus 480. So to factor this, what GCF can I pull out? I can at least pull out a what? What could I pull out? I can pull out a 4. So that's going to give me a 3x squared minus 184 divided by 4 is going to give me 46x. And then plus 120. Now, would I give you this large of numbers on your test without a calculator? No. So I have to solve by factoring, or if you had your calculator, you could use your zero function. But again, if I factor this, it's going to factor into x minus 12 times 3x minus 10, just to save time. So then what are the critical numbers going to be here? It's going to be when x is equal to what? X is equal to 12 and x is equal to 10/3. Now check both these answers. Are there any answer here that's not going to be a reasonable answer? Yeah, Ian? Why? How come 12 is not reasonable? Exactly. So does that make sense? So notice, remember what we said, one of these sides is going to be 16 minus 2x. So if I actually plug 12 back in here, I'm going to get a negative. So this is not good. It's going to be out of the range of possibility. So right away I know that I at least only have one number to check. So again, I'm looking for a relative max. So again, to confirm that 10/3 is indeed a relative max, I know that this is equivalent to 3 1/3, so I can plug in a 4 into my derivative. So 4 minus 12 is negative. This is positive, so this is indeed going to give us a negative. Plug in 3. 3 minus 12 is negative. This is negative, so that's going to give me a positive. So it is indeed a max. Does that answer the question? What is the question asking you for? What size should the squares be? So the size of the square is going to have a length and have a width. So these squares are going to have to be a 10/3 by 10/3 inches actually, by 10/3 inches. So that is your final answer to that particular question. This is a very common optimization problem, cutting out the corners of a box. So any questions on that particular example there? A cylinder can. Now, you have to pay really close attention when they tell you that the top is closed or open. They're telling you that cylinder can closed at the top. It holds 800 cubic centimeters. What is that in relationship to this can? This is your what? Volume. So here's my, again, we're assuming this is a right cylinder. It should probably say right cylinder in the problem. So now the volume of a cylinder. Do you remember that particular formula? Pi r squared times h. So in this particular case, I know that my volume is equal to 800 cubic centimeters. Find the height and the radius. So I'm solving for the height and the radius. That minimizes the amount of material needed to manufacture the can. So think of your soup cans. When we talk about the material, that aluminum that's needed to make the can, we already know the volume is 800 cubic centimeters. What formula are they asking us to minimize? Are we minimizing the volume formula? No, we're going to minimize the what? Surface area, the surface area. This is where it makes a difference whether or not the can has a closed top versus an open top. Because when you have a can, the shape on the top and the bottom of the can are circles. And what's your area formula for a circle? The area of a circle is pi r squared, correct? So to calculate the area of the top and the bottom of the can, this is where it makes a difference into a closed top versus an open top. Because this is a closed top, how many circles are going to make up this cylinder? 2. So it's going to be 2 pi r squared. So that takes care of the area of the circles of the top and the bottom. If this was an open top, instead of just writing 2 pi r squared, it would have to be a what? Pi r squared. All right, so that's why you need to be careful when you're reading these questions. Plus, now, do you remember how you calculate the area of the rest of the can? That's going to be 2 pi r h. So like I said, this is the part that you have to be careful of with the cylinder problem. Again, if it's an open top, then you would just have a pi r squared here, because you have the top and the bottom to consider in this particular case. You have to put 2 pi r squared. Now, just like some of the related rate questions, remember they gave you information about volume to start with. One of the formulas is for substitution purposes only. One is going to be that you're going to maximize or minimize. So before you start taking the derivative, you would run into a problem, because notice you've got a surface area formula that's with 2 different variables. So this is where you're going to want to rewrite this formula in terms of just one variable. So again, that's where I'm going to use this volume formula. I'm going to take my volume, my 800, is equal to pi r squared times h. Now, looking at the surface area formula and looking at your volume formula, it's much easier to rewrite this surface area formula in terms of r versus h. Because if I try to solve this for r, then I got to deal with square root. So it's much easier to solve this equation for h. So my height then is going to be equal to 800 divided by pi r squared. Now what I can do is I can take out the h out of my surface area formula and just rewrite it in terms of r. So when you're dealing with these formulas, if you have more than one variable, they typically will give you something for substitution purposes. Again, you want to clean this up as much as possible before you do the derivatives. So again, I can cross out this pi. I can cross out, so my surface area is going to be equal to 2 pi r squared, plus that's going to be 1600 over r. Or another way I could write this before I do the derivative is 2 pi r squared plus 1600 times r to the negative first. So I don't have to go through using that quotient rule. So any questions on how I cleaned up the surface area formula? So now I'm ready to take the derivative of the area with respect to r. So the derivative of 2 pi r squared is going to be a 4 pi r. Plus, using my power rule, this is going to be negative 1600 r to the negative second. So now I'm going to have to take this derivative and set it equal to 0. So 0 is equal to 4 pi r minus 1600 over r squared. Now, in order to solve this equation, again, remember what I want to do is I want to figure out the critical numbers. So I do want to condense this down to a single fraction, getting a common denominator. So again, 0 is going to be equal to multiplying this by r squared over r squared is going to be 4 pi r to the third minus 1600 all over r squared. So now remember where the critical numbers are going to come from. It's where the derivative is equal to 0 or where it's undefined. But is it really reasonable to have an r equal to 0? We're making a can no matter what. So it's not reasonable to have r equal to 0 in this particular case. So what I need to consider is just setting that numerator equal to 0. How do I solve that? What's going to be the first step? Add 1600. Then what? Divide by 4 pi. So r to the third is going to be equal to 400 over pi. Then what? Take the what? Then I'm going to take the cube root. Where's my calculator? Obviously, knowing where 400 over pi is on the number line, I wouldn't expect you to know off the top of my head. So again, let's figure out what this decimal equivalent is going to be. So this is going to be approximately equal to the cube root of 400 divided by pi, which is about 5.031. So any questions on that particular problem? So again, I want a minimum. So I can plug this in my number line, do my number line test. So again, when I plug in a 5, I know that this is going to be 5 cubed is 125 times pi times 4 minus 1600. That's going to give me a negative. This is going to give me a positive. So it is indeed going to be a minimum. So now, what is this 5.031 in relationship to what they're asking me to? They want me to find the height and the radius. So what is this 5.031 just tell me? It tells me what the radius should be. So my radius should be about 5.031 centimeters, or the cube root of 400 over pi. How do I figure out the height? Because the question's asking me not just about the radius, but it's asking me about the height. Yeah?
You put in 5.031 into 800 plus pi or h.
Yeah, or it's already solved for h.
Yeah.
So again, use that store feature on your calculator. You'll get a much exact answer. I already have the cube root of 400 divided by 5 loaded in. So store it in your calculator. So that I can just type in 800 divided by, and again, make sure you put parentheses around that pi, and then I'll just do x squared. So about 10.062. Is everybody familiar with that store button on the calculator? You want to use the exact form of the radius as long as possible. So again, what the store button will use, so when I typed in that cube root of 400, those of you that aren't familiar with this button, the cube root of 400 divided by pi, this takes it out about 100 decimal places. So it's in your calculator memory, you don't see it. So when I round it to 3 decimal places, I'm not getting a very accurate, it's not as exact, it's not going to be an exact answer. So what I can do is I can tell my calculator, hey, I can store this in for any variable that I want. The store button is located right above on. So I can hit the store button, and I can store it in for any letter that I want. So I'm going to go ahead and store it in for x. So now anytime I hit an x on my home screen, like 5x, the calculator automatically dumps in that x value that I have stored in with all those stored values up to 100 decimal places. So it's giving you a much better answer versus rounding it. You don't want to use a rounded answer to round another answer and then perhaps another rounded answer. You're getting further and further away from the value that it should be. So any questions on your cylinder can problem? All right. Another type of problem that they give you with these optimization is talking about distance. If you remember your distance formula from geometry, the distance formula, remember, is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So anytime they're asking you to maximize or minimize distance, you're really caring about making sure you minimize or maximize the value that's underneath the radicand. Because I know the smaller number that's underneath this radical, the smaller the number is going to be, or vice versa, larger. So when you're dealing with these problems that involve maximizing and minimizing distance, ignore the radical, because really what you want to do is you want to minimize or maximize the number underneath the radicand. That'll make it easier for you. Hyperbolas. Do you guys remember about graphing hyperbolas? No. You don't remember ellipses and hyperbolas and all that fun stuff? Do you remember what the standard form of your hyperbolas and ellipses are? They always have to be equal to what? 1. So the standard form of your hyperbola and ellipses, if I divide this whole entire equation by 4, it's going to be y squared over 4 minus x squared over 4 equals 1. Let's take a look at the graph. Flashback to, I guess you guys do this now in pre-calc. Where's the center of this hyperbola? We used to do it back in Algebra 2, back in the day when I taught Algebra 2, but now I think it's in pre-calc. Because I know I did it last year in pre-calc. 0, 0. Do you remember what you do with the denominators to help you start sketching it? Square root. So I'm going to go take the square root of both denominators. That's going to be the square root of 4, which is 2. So I go 2 units to the left and right of the center, 2 units up, 2 units down. If this was a ellipse, you have just found your vertices and your co-vertices, and you would draw your oval. Remember, the ellipse looks like an oval. But what do you do with this hyperbola? Do you remember? Do you remember making this rectangular box? Yep. Oh. Then what'd you do? You draw the asymptotes, which are the diagonals. Oh. Really? I have to remember how to do this from pre-calc? Yeah. Now remember, with the hyperbolas, you have 2 branches. The branches could be opening left or right, or they could be opening up or down. Do you remember with this hyperbola which way they're going to go? It's going to go up and down, I agree. And remember, you use those asymptotes in the box to help guide you through making the branches? How did I know from looking at this equation of y squared over 4 minus x squared over 4 that the branches were opening up and down and not left and right? It's the y squared is first. The y squared is not negative. Whatever fraction is positive, that tells you y goes up and down, so therefore the branches go up and down. If it was x squared over 4 minus y squared over 4, the branches would be opening left and right. Okay? So there's my hyperbola. So what's the question asking me for? It wants me to find the points on the hyperbola that are closest. Closest is another phrase for minimizing. The point 2, 0. So there's my point 2, 0. Now looking at this illustration, how many answers do you think you're going to have? Are you going to have 1 point or 2? 2, exactly, because again, I know that these branches are symmetrical over the x-axis. So if I have a point up here that's the minimum distance to 2, 0, there's also going to be another point down there. So be on the lookout, I'm going to have 2 answers. So now let's talk about how I'm going to find these points. So part A. So everybody good on the graphing the hyperbola? So now I'm going to write my distance formula. This is the formula I'm trying to minimize. The point that I'm trying to get closest to is 2, 0. So what I'm going to do, I have an x value, I have a y value. I'm going to plug this into my distance formula. So I'm going to have x minus 2 squared plus y minus 0 squared. So I'm going to go ahead and I'm going to, because I know eventually I'm going to have to take the derivative of this particular formula because I'm trying to minimize this particular distance. So when I FOIL this, this is going to give me x squared minus 4x plus 4 plus y squared is equal to that distance. So I would run into a problem right now if I tried to take the derivative. What would the problem be? I have a dy dx in there. But I do remember have my hyperbola formula equation y squared minus x squared is equal to 4. So again, remember what I can do is I can take out this y squared and replace it in terms of x. So y squared is equal to x squared plus 4. So now I can take out that y squared and replace it with an x squared plus 4. So x squared minus 4x plus 4 is plus x squared plus 4 is equal to the distance. Again, clean this up as much as you can. Combine like terms. So x squared plus x squared is a 2x squared. Minus 4x. And 4 plus 4 is 8. Now I'm ready to take the derivative with respect to x. So that's going to give me 4x minus 4. Any questions on how I found that derivative so far? So now, to find the critical points, I have to take this derivative and set it equal to 0. So I can factor out a 4. So what's x going to be equal to? X will be equal to what? 1. And again, if I do my number line test, I plug in a 0. 0 minus 1 is a negative. If I plug in a 2, that's a positive. So it does indeed check out that it is a minimum. Does that answer the question for part A? Read the question carefully. Does it answer, again, we're not talking about part B, we're talking about part A. Does this answer the question? No, because a point has a what? X and a Y. So I know that it's going to have 1 comma something. How do I find the Y coordinate if X is equal to 1? I'm simply going to do what? Plug it back into the original. So again, Y squared is equal to 1 plus 4. Remember from my diagram, how many answers should we be looking for? We're not looking for just 1, but we're looking for 2. So what's y going to be equal to? Y will be equal to plus or minus square root 5. So 1 square root 5, and then 1 negative square root 5. So what you just found is the points on the hyperbola right here when x is equal to 1 that are closest in distance to the point 2, 0. So any questions on how I found the answer to part A? So now let's talk about part B. What's part B asking you for? What's part B asking you for? The closest what? Distance. Well, now I know my point. I have 2, 0, and I have 1 square root 5. Will you agree with me the distance between 1 square root 5 and 1 negative square root 5 is going to be the same to 2, 0, correct? So here's where they actually want me to calculate using the distance formula. So I have 2 minus 1 squared plus 0 minus square root of 5 squared. So I have square root of 1. What's negative square root of 5 squared? That's just going to be 5. So the distance is square root of 6. Okay. Any questions on B? You guys go ahead and set up example 6A for me. See if 4y to the third plus 2y plus 6. Even if I factor out a 2, I'm running into a problem. Because I know I'm going to have to take this derivative and I've got to set it equal to 0. So 0 is going to be equal to 4y to the third plus 2y plus 6. This brings me back to Algebra 2 land, and I think I mentioned this on one of the homework assignments earlier. How do I solve this without a calculator? Synthetic division. You remember that P over Q test? Oh, no. Remember, you take the factors of 6. I mean, you could factor out a 2, but you're still going to have to do it. Factors of 6 divided by factors of 4. So you'd have to do this list of plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All of your factors of 4, plus or minus 1, plus or minus 2, plus or minus 4. You do the 1 over 1, the 2 over 1, the 3 over 1, 6 over 1. Then you do the 1 over 2, 1 over 1, 1 over 4. Take your long list of numbers. And then you have to try to do synthetic division until you got to a remainder of 0 to figure out which one is actually a root or a 0 to start breaking this down into a quadratic. It's like, wow. What was this? Algebra 2 probably? Probably. So just for kicks and giggles, let's try negative 1. Let's see if negative 1 works. Remember, you have to put a placeholder because you're starting with a y to the third and you're missing a y squared. So you have to put that placeholder where 0 is. So again, drop down your 4. That's a negative 4. Add on the inside. Multiply on the outside. Imagine that it works. So again, I know then that I can start breaking this down into factored form into x plus 1 times. Dropping this down a degree, that's a 4x squared minus 4x plus 6. Now that it's down to a quadratic, I'm going to take out that 2, and that's a 2x squared minus 2x plus 3. Can I factor that quadratic? Can I factor 2x squared minus 2x plus 3? Can it be factored? Are there any factors of 6 that add together give you negative 2? I don't know which technique of factoring you've been taught. There's so many techniques out there now. Some of you do Nike, just do it. Some of you may do slide and divide. Some of you may do all kinds. Guess and check, yeah, that works too. But the problem is, this can't be factored. This can't be factored. And this is where, instead of wasting your time to check for those irrational roots, use the discriminant, that b squared minus 4ac, because remember, if that discriminant is less than 0, you know that this quadratic has imaginary solutions. So b squared is 4 minus 4 times a times c. So what kind of solutions would come from here? They're not going to be real, they're going to be imaginary. That's the benefit of remembering that discriminant. When you have a problem like this, you don't want to waste your time setting up a quadratic formula. You've already done enough work. But if you know that the b squared minus 4ac is less than 0, don't waste your time because this has to have imaginary zeros. So there's only one critical number here. What's the only critical number? -1. All right? So now x equals -1. So now I can go ahead and start answering the question. Question's asking me, find the point. So this is not a point. This is just an x coordinate. How do I find the y coordinate? I'm going to plug it back into my original equation. So if x is equal to -1, what's the y value going to be equal to?
Y equals -1.
So then x is going to, so -1 plus y squared is equal to 0. So y squared is equal to 1, so y is just going to be 1.
Isn't y -1? No, y is -1.
Oh, that's right. You're right. It should be y is -1. You're right. That's my mistake. So I have it backwards. 1, -1. Sorry about that. Yes, because I wrote everything in. I solved for y. Should be y. Thank you. It was originally y. Yeah, I solved for y. I'm sorry. Thank you. Yeah. Yeah, I solved for y. Remember, I solved for y in the beginning. So x is equal to -1. Or +1, yeah. So any questions on those? Part B, closest distance. Go ahead and calculate that distance for me now that we know the point.
It's supposed to be -1 now.
Oh, yeah, it's still -1. Yeah, there's something was wrong. -1. -1. Yep. Yeah, I can do my basic solving of equations. Say -1, -1. You're right. Thank you. So now calculate the distance. Again, your point is 0, yeah, because it's x plus y squared. We solve for y. So x plus 1 is equal to 0, so x is -1. So the point's -1, -1. Yes, Izzy? I'm sorry, Izzy? Mm-hmm. Right, exactly, right. You just don't want to do the derivative with two variables in it, because then you get into the whole dy something. Yes. Okay. That's the whole point of trying to rewrite it in terms of just all x or all y, so you don't get into all that. What'd you guys get for the distance? Square root of 5. Very good. You get square root of 5 as a distance. All right. So any questions on that one? All right. One last thing, because it may have been a while. What does the graph of x plus y squared equals 0 look like? We know it's a parabola because it's telling me that in the part A. But the parabolas can open up, down, left, right. So the question is, which way is this one going? Well, hopefully you can at least narrow it down to one of two directions. Because it's a y squared, it's going to have to open one. It's not x squared, it's y squared, so it's going to have to open left or right. Solve for y. So y squared is equal to -x. Maybe that'll help you now. So we've narrowed it down, left and right. Which way is it going to go? To the left, because of the negative sign on the one side. Where's the vertex of this parabola? 0, 0. So that's what the graph of x plus y squared looks like. And again, what you just found, the point 0, -3. the point on the parabola that's closest to 0, -3, is at -1, -1. So that's what you just calculated. Okay? So those are those are some common optimization problems out there. All right, so any questions about the max, again, optimization or max or min? All right, guys, take out your laptops and log into your